Good morning, everyone, and welcome to the first panel of Industrial Ethernet Week here at HARTING. We're excited to talk to you today about the intersection between industrial design and sustainability goals. There are quite a few challenges facing manufacturers like HARTING and those of you on the phone, so we're excited to dig into those today with our panel. I'd like to start with introductions. My name is Casey Spitz. I'm responsible for development and innovation here at HARTING's Americas.
Hello, thanks everyone for attending. I'm Vivek. I'm the head of our innovation group in Cambridge, Massachusetts. Glad you're all here.
Hi, I'm Michael Prince. I'm president of Beyond Design, a product development firm located in Chicago. Thank you for inviting me.
Hello, I'm Noah Young. I'm an industrial designer at Beyond Design with a background in design for sustainability.
Excellent. Our primary goal for today is to talk about, as I mentioned, the intersection between sustainability and industrial design. And before we jump into that, I think it's important to discuss what are the challenges that are facing manufacturers today, and then we'll dig into some of those one by one. The first challenge that we're going to talk about in just a few minutes is really how to manage all of lifecycle management through the lens of sustainability. You can't just talk about sustainability after a product has been designed. So we'll dig into that in just a few minutes. The second topic is really the newness of ESG and sustainability for major manufacturers. How are companies handling that in their policies? How are individual employees handling that even at the design level? And then finally, we will talk about the elephant in the room, cost. How is that integrated into sustainability, and how can us as manufacturers help our consumers bear that cost? So to dive in, we'd really like to start talking about the challenges of design and industrial design for sustainability. Noah, I'd like to start with you today. Can you speak to those challenges and how employers and how manufacturers can handle them?
Yeah, so something that we find at Beyond Design as a design consultancy is that a lot of times the companies that we work with want to account for sustainability at the end of the process, but in reality, sustainability has to be accounted for from the design and engineering from there on, and every step in between. So the sooner that you can have that plan in mind for how this is going to be a sustainable product, the more successful and the more real-world impact you'll be able to make in the future.
Perfect. I think we have a visual that we can share that shows the life cycle process. Any steps that you'd like to highlight in this process?
So yeah, I mean, it's a very simplified version of the process. There should be a lot more loop-de-loops here in terms of going back and forth, but we're coming from the perspective of that design and engineering, and that's really where this all begins. But every step you see here on this graphic is somewhere that sustainable practices can be implemented. And specifically towards the end, something that we always emphasize is the end-of-life education. That's something that doesn't get accounted for almost ever until it gets to the final resting place, and by that time it's too late.
Really great points. Michael, anything you'd like to add here?
So it's really important from our perspective on the design side that we understand where the product is going to lie, whether it's a professional product or whether it's a consumer product, and looking at, from the design standpoint, the materials that are going to go into this, the sustainability that will affect, but also the longevity of the product. Sometimes we have to use virgin materials, while in other cases we're trying to use more composites that are recycled or regrind to actually reuse the materials, but it really depends upon the application. So we work closely with our clients to really understand what the applications are so we can choose the right materials.
Perfect. And I know that we will take some time to dig into the material side, but I do also see this IIoT shape right here in the middle. And this is huge for HARTING. We spend a lot of time thinking about IIoT. Vivek, could you speak a little bit to how the emergence and the huge expansion of IoT in the production floor intersects with sustainability?
Yeah, no, absolutely. It's a very critical part of being able to really understand and measure and control emissions throughout the entire product life cycle in manufacturing. So, for example, Lucas brought up an excellent point in his introduction that 97% of emissions are really out there in the supply chain. That starts all the way back at raw materials through preliminary processing, through manufacturing, warehousing, distribution, and at each point, the industrial Ethernet will enable us to effectively measure, because we cannot control that which we are not measuring. I mean, that's like a fundamental axiom. So the power of the industrial Ethernet is really the ability to measure at the raw material stage. For example, a lot of companies now are looking at electrification, even down at mining equipment. And so you're able to get a really good understanding of what's happening at the raw material source. Manufacturing has traditionally been the home of IIoT and Industry 4.0. That's where it grew up, essentially. The fourth industrial revolution is Industry 4.0. So in manufacturing, people have already been utilizing this. But for example, now you could use energy as a variable in production. So if I can delay something a week, I could maybe shut down 3 or 4 milling machines here, a couple of lathes here. All of that adds up cumulatively, when you look at the overall greenhouse gas emissions. Warehousing is a really good point. And here again, Lucas had brought up the fact, between shipping via boat, air freight, truck, they all have their consequences. And here again, what we've seen in warehousing is a tremendous expansion in the use of IIoT tools to understand exactly what's going on, where the products are, where they're going, how much energy you're consuming within the warehouse. That's become a really big thing. Information is part of manufacturing. Manufacturing consists of materials, methods, and information coming together to make a product. And here again, the advent of data collection and AI and sensors is driving, the growth in data centers, but data centers obviously consume a lot of energy in and of themselves. So, IIoT is a very powerful tool for understanding where energy and resources are flowing within the entire product ecosystem, and eventually to be able to control these and, really systematically bring down emissions.
Excellent viewpoint. Michael, I know at Beyond Design, you work with an incredibly diverse set of customers. Can you talk about how they're handling IoT and how the design is contributing to that with a sustainable view?
Well, a lot of our customers, it'll vary from a consumer product to industrial product. So it really depends upon the customer and the importance, and comes a lot down to the cost. More of our customers are starting to look at alternatives rather than just automatically going to China. They're trying to bring it back locally. And they are understanding that by having it locally, they have better control. While their cost might be slightly higher, they have less on the inventory, so they have less risk. So all of these factors that we're talking about come into play, and that's causing an effect on where manufacturing is happening, as well as how it's being shipped, and ultimately where is it being stored. So for our standpoint, it's affecting every aspect of that design, because we need to make sure that it's going to fit within that system.
Perfect, thank you. So we'd like to talk about what I mentioned before, the elephant in the room, about sustainability, cost. A big aspect of what we think about is, our customers have a need for sustainability. How can we build in that need in a cost-neutral way? Sometimes that's possible, sometimes that's not possible. So what I'd love to talk about is, in that spectrum of what the market will bear versus the manufacturer needs to cover, what can designers and manufacturers do to address the need to drive sustainability while keeping the costs down? And I'd like to start with the Beyond Design team on this one.
From our perspective, we're the consultant, so we have certain amount of suggestions and education. I think it all comes down to education, but ultimately we don't have that final say on where it's going to be manufactured and assembled ultimately. So what we try and do is educate our customers through participating in events like this, so that we can let them know that there are alternatives. The alternatives aren't necessarily about changing of materials. We like it to start there, but sometimes it's really about the education and designing for disassembly, or designing so that we can remove certain parts out of the product, such as a lithium-ion battery, before it gets into a landfill. So we're looking at design and trying to educate our customers on how they can do a better job to be part of the system.
Yeah, I would just say, like, one example of things that we've actually in real world talked to clients about before and tried to push them to implement is, for larger companies, using recycled materials can come with hazards. The quality of the material, does it have the same characteristics that you need? So if you are a larger company and you need that control over your material, there is the opportunity to not only be more sustainable, but also save costs by possibly implementing an in-house recycling program. So you're keeping your your product stream in-house, you're maintaining that quality, there's nothing else getting in there. Again, this has possibly a higher upfront cost, but in the future, you're not having to get virgin materials off, and it will be cheaper, in the near future.
Vivek, can you share your perspective as well?
Yeah, I mean, one of the things that we're seeing, which is a very positive trend, is the ubiquitous use of digital design tools, simulations, and virtualization, and the whole concept of digital twin. Actually starting all the way back at the design phase, through the manufacturing. This allows us to, I think, really reduce the overall amount of effort to optimize, different products, and also to, really powerfully leverage the use of simulation tools that can reduce sort of the design life cycle, but also take into account all these other optimization factors, such as material usage, energy, design for total life cycle. How do you, what's going to happen at end of life for this product. So that's one of the very powerful aspects, I believe, of Industry 4.0 is the entire concept of the virtualization shell, starting all the way back at the design process through manufacturing and ultimately through end of life, is definitely going to help, companies to meet their sustainability goals. And here again, the industrial Ethernet plays a key role because the industrial Ethernet allows you to connect the digital world to the real world and to be able to see, how these two correlate. So it's a very important aspect.
And we hear a lot about digital twins, virtualization. Can you paint for a picture for the audience the difference and maybe the intersection between digital twin and simulation?
Yeah, so it's not just a CAD model. It's much more than that. You can think of it as basically also embodying all the different aspects of the physical object. So it's really the handshake where the cyber and physical worlds meet. And why is this useful? It's useful because it can drive, simulation. So, for example, very recently, one of the big airports in the world at London Heathrow, they implemented a new baggage handling system, and many of our customers are in that area of baggage handling and logistics. The entire process was simulated, to begin with, and that was a tremendous savings in terms of cost, installation, just time, to be able to get this up on time. And so we're seeing more and more very powerful implementations of digital twin with simulation, and with optimization tools, increasingly AI-driven optimization tools, which are, enable basically the product to be commissioned in a much faster time frame, and also at lower, overall energy costs.
Perfect. And what I'd like to ask the audience to do, please drop in any questions that you may have. We have moderators here that are standing by. You have the perfect segue to the first question we received, which is about AI. So besides sustainability, AI is probably the most talked about thing on LinkedIn right now. And Vivek, I'd love to kick this over to you. Is AI hurting sustainability? Is it helping sustainability? Do people know what AI is? Can you speak to this?
Yeah, so it's a really good question. So first of all, nothing is free. AI costs energy. And when you look at these gigantic models, these so-called deep learning models that are in the cloud, they consume immense amounts of energy. So on the one hand, AI is a powerful tool in helping people meet ESG goals. On the other hand, it's also driving a lot of greenhouse gas emissions in and of itself, due to the fact that it really does take a lot of power to run these massive models. One thing that the industrial Ethernet could enable is a very powerful concept called edge computing and edge AI. So instead of having the big AI in the sky, imagine if you could have many distributed models, down on the shop floor, in the warehouse, at the customer site. And what you can do is pre-process a lot of this data, this torrent of data that, again, Lucas mentioned, that we're facing an exponential increase, in data. So how do we manage this effectively? Not all of that has to go to the cloud. What if you could very effectively pre-process a lot of it, derive some insights right at the machine tool, right at the manufacturing site, right at the warehouse, and then utilize AI at a cloud level to basically disseminate these insights across an enterprise? And so I think the future in AI, at least for the industrial environment, is going to be a combination of edge computing, localized data reduction, localized insights combined with the cloud level. And this will result in an overall a more energy efficient implementation of AI, but it'll also give customers more control over their data and their insights. And here again, I feel the industrial Ethernet is very critical to enabling this because it's basically the data highway, the data backbone that's going to enable all of this to happen in the future.
Excellent. Thank you. We have one more question in from the audience, and I think it's based off of the discussion that Noah and Michael were having earlier about alternative materials. So can you talk a little bit about where you see some of the experimentation happening with alternative materials? Is it more on the consumer side? Has it hit mainstream B2B applications yet? And where are we in that technology adoption curve?
Let's take it.
Yeah. I think where we see, I mean, first and foremost, where we see a lot of experimentation with sustainable materials is in packaging. It's, it's the shortest step to go in terms of, changing your materials up. So, going from a plastic clamshell to maybe compressed paper pulp, the cost isn't that crazy of a jump, and, the longevity of that product for sitting on a shelf is going to be roughly the same, but you have that recyclability aspect. We are starting to see companies more and more, willing to take risks when it comes to consumer products. A lot of, home products, home goods, things like that, that don't have, again, that real materialistic need to be, super durable or meet crazy standards, because, it still is, we're still experimenting with these. And there are still a lot of great alternatives out there that meet those needs. They're just, a little bit tougher to make, a little bit more expensive. It's in its infancy.
And just kind of to add to that, one of the customers that we're working with, it has to do with foam and paper. And so the foam that they're using is not recyclable, at least from the standpoint from the recycling plants. There's no value to it. There's not enough monetary to come back to them for recycling that material. And so if we were to change that material to where they could accept it, the question then comes, well, we've been trained not to accept it, so they need education so that the change is now going to be able to fit right in and streamline with their system. Because of that, it comes back to education about these new materials.
And you're seeing that both on the design side as well as the consumer side, the education?
Yes, especially on the manufacturing side, because they're so used to using, a typical ABS or a polypropylene, and to start looking at alternative materials, their questions are really coming back to quality. And so someone's got to take that faith and actually do that testing to change the materials to then push it forward. As more and more companies start to change the use of the materials, going from the bad materials to the good materials, the prices will come down and it will be more affordable and it will start to change. But it's just now starting to happen where customers are asking for what those alternatives could be.
And just to add one more brief comment on that, just on the as product developers and designers, there is the aspect of sometimes what seems to be a sustainable material isn't necessarily the most sustainable option. It might be great in one aspect. It might, be the best for it's not a great term, but greenwashing, it makes your product look really good. But again, what Michael's saying is like those end of life processes, if there's not infrastructure there yet, that material is just as good as, a traditional ABS, because it's going to end up in the landfill anyway. So being smart with your sustainable choices.
Perfect. Thank you very much. We have a great question that's coming from the audience. So prototyping and testing were on the life cycle loop that we showed earlier, and maybe we can pull up that visual once again. Can our panelists comment on how prototyping and testing changes when you're designing for a future sustainable environment? Maybe, Noah, I can start with you.
Yeah. So I think something that we're seeing a lot, and something that Vivek touched on, was the kind of like the digitization of prototyping. So we, right now as a product consultancy, we do a lot of physical prototyping with 3D printing, getting parts, CNC'd, manufactured for small scale, which in that aspect, the carbon footprint isn't huge. But when you get to the engineering side and you need to do more rigorous testing and getting production models, I think the digital twin and using the various AI programs to, improve on that rather than physical prototyping is kind of the future.
I would also add to that, we've been into 3D printing for probably about 2 decades, decade and a half. And what it's done is it's sped up our process, and we go from a concept to an idea. We take that sketch, we put that into CAD. We're then able to 3D print that, and within a couple of hours, we're able to then physically evaluate and test that. And if you compare that to the older ways, we would have to take that, do detailed drawings, send the drawings out, get quotes on them, then be able to get the parts back, then do the evaluation and start that process all over again. So from our customer standpoint, we're able to work extremely fast and prove out and prove what is going to work and what's not going to work so that we can keep moving forward on the program. So we haven't actually added up to figure out what that reduction is in our digital footprint. But I can tell you the time that we've saved has probably been tenfold just because of going digital.
Excellent. We have one last question from the audience. After we answer this question, we'll take a short break and then we'll come back for session 2 of this discussion. So Vivek, this question seems perfect for you. The question says, the GPU chips for AI reduce the number of CPUs in the backend system, which of course has a positive impact on the environmental footprint for AI applications. Can you imagine replacing copper with optical I/O to enhance data performance in the communication level?
So, I mean, this is a really good question. So, there are multiple aspects to this. First of all is the computational platform. Secondly is the communication protocol. So I'll address these two separately. What we're also seeing is a potential blurring of the lines between hardware and software. So you're having chip designs come out right now that are specifically designed for AI and that are very computationally efficient, energy efficient. But there's also a software trend called, TinyML, compressed models, where basically I can take a gigantic model that may be running in the cloud, I can shrink it down to something that could even run on a 32-bit microcontroller. So I may not even necessarily need a GPU or a CPU. And when we look at all these different hardware options, especially in light of edge computing and cloud computing taken as a symbiotic system, as it were, that's where you could really, realize some savings. So let me get very specific. Say, for example, I'm looking just at 3-phase power. So I'm really measuring only 6, variables, 3 voltages and 3 currents. I could design a very efficient AI to basically analyze that, look for faults, even do things like predictive maintenance, based on the power consumption of that specific machine. And here again, industrial Ethernet is going to be a key to getting that data in and out, of the production environment. Now, to address the the communication protocol, typically, we always think of fiber optic in terms of long distances, Ethernet access, things of that nature. Increasingly, the sensor load in manufacturing and in supply chain and warehouses is getting so big that we may actually see fiber optic, for example, in the next generation mobile robots, AMRs, in warehouses that are collecting tremendous amounts of information. Imagine an autonomous mobile robot that has to basically navigate itself and avoid collisions with people, equipment, other robots, to get things in and out of a warehouse. That level of computation requires a lot of sensors. And so we're even seeing instances in which fiber optic may be actually very valuable as a connectivity tool in the industrial environment. And so there also arises this need for sort of a media conversion, going from copper to fiber. And that's very vital. And so these are all, areas in connectivity which are vitally important, as we look to the future. And, I believe industrial Ethernet has a very big role to play in that.
I knew that would be the perfect question for you with your background and experience. So we're going to take a 5-minute break. I'm going to leave you with an Industrial Ethernet Week cliffhanger, the first time we've ever done this before. So when we come back in just a few short minutes, the question that we'll start with from the audience: what are some practices your average consumer can implement to contribute to a more sustainable product life cycle? We'll be right back.